So we all hear about the nuclear renaissance, right? Dozens of new reactors are being planned all over the world. But what if the entire industry is overlooking a massive front-loaded demand for fuel? Today, we're going to dive into a potential blind spot in the uranium market that could have absolutely huge consequences for the future of nuclear energy.
So let's just cut right to the chase. The central question of this whole explainer: is the nuclear industry seriously miscalculating its future fuel needs? Because, some analysis out there suggests the answer is a resounding yes, and by a margin that is honestly pretty shocking.
And that brings us to our first section, and a number you're going to want to remember: a potential 100,000-ton blind spot. Now, this is a number so big it could fundamentally reshape the entire uranium market for years to come.
That's right, 102,000 tons. One perspective suggests there's over 100,000 tons of uranium demand that standard forecasts might be completely missing. Now, to put that into perspective for you, the entire global demand for uranium right now is around 69,000 tons a year. So yeah, this hidden number is truly enormous.
So where does a number like this even come from? Well, it all boils down to a concept called the initial core load. The easiest way to think about it is like the first full tank of gas a brand new car needs. It's this huge one-time fuel requirement just to get a reactor started, and it's totally separate from the regular annual refueling it'll need down the road.
So why is this a potential blind spot? Well, because most forecasts are really good at tracking the steady, predictable, annual fuel needs of all the reactors that are already running. But these massive, one-off initial core loads for new reactors, they just don't fit neatly into those models. And that's exactly where a major miscalculation could be hiding in plain sight.
Okay, so here's how we get to that shocking number. This first analysis points to about 170 new reactors in the pipeline. Now, if each one of those needs somewhere between 600 and 800 tons of uranium just for its initial core, well, you do the math. You get a staggering 102,000 to 136,000 tons of hidden demand. This is what you might call the crisis scenario. But hang on a second. Is that number really right? Let's deconstruct the math here, because there's another, very different way to look at this whole problem.
And this is where it gets really fascinating. A different analysis looks at the exact same problem but comes to a vastly different conclusion. It asks the most important question: are those initial assumptions actually correct?
This slide just lays it out perfectly. On the left, you've got that alarming view. On the right, a much more conservative calculation. The number of reactors is pretty similar, right? But the absolute game changer is the fuel per core. Instead of 600 to 800 tons, this view says it's more like 190 to 250 tons, and that brings the grand total way down to between 30 and 40,000 tons. Now, that's still a huge number, but it's not the market-breaking crisis we saw in the first view.
So the whole story hinges on this one thing. How much uranium does one new reactor actually need to get started? The difference really just comes down to assumptions about reactor size and efficiency. One estimate points to a supply crisis, the other points to a significant, but maybe more manageable, market pressure.
And to really get why this front-loaded demand matters so much, no matter which number you believe, we need to talk about what's called the first tank problem.
This quote from the source material absolutely nails it. I mean, think about it. You can track annual gasoline consumption perfectly. But if you forget that every single new car sold needs a full tank of gas right away, you're missing a huge piece of the demand puzzle. And that is exactly what the initial core load is for the nuclear industry.
And look, getting that first tank of nuclear fuel isn't an overnight process. We're talking 3 to 5 years from start to finish. It has to be contracted for, then mined and milled, then it has to go through conversion and enrichment, and finally, fuel fabrication. So what that really means is that utilities planning to start a reactor in, say, 2030 need to be securing that uranium right now.
Okay, so when you put these two perspectives together, what's the most likely outcome? Well, it seems to point less toward a sudden dramatic crisis and more toward a sustained long-term market squeeze.
To understand this squeeze, you've got to look at the market we're already in today. It already operates with what's called a structural deficit. The world's mines produce about 58,000 tons of uranium a year, but the world's reactors consume about 69,000 tons. So for now, inventories and other secondary supplies are filling that gap.
Now let's add that initial core demand on top of it. Even if we use the lower, more conservative estimate, that's another 3,000 to 4,000 tons of demand every single year for the next decade. This takes an already tight market and makes it even tighter.
It pushes that annual deficit from around 20% up to maybe 25 or even 30%.
So what does this mean in the real world? Well, for one, sustained support for uranium prices. It means existing stockpiles suddenly become a lot more valuable. It creates an urgent need for investment in new mines to come online. And for the utilities, it means they absolutely have to lock in their fuel contracts much, much earlier than they have in the past.
All of this brings us to our final section. What is it actually going to take to fuel this nuclear future we keep hearing about?
You know, in all this, timing is everything. Right now, utilities are in the contracting phase for their future reactors, but the real demand pressure, the peak of this wave, is expected to hit between 2027 and 2032. After that, as these new reactors finally come online and switch over to that predictable annual refueling, the market should start to stabilize again. The real challenge is navigating that 5-year surge.
Okay, so let's just boil this all down. What have we learned? First, a front-loaded demand of at least 30 to 40,000 tons of uranium is on its way. It's probably not the crisis some fear, but it's for sure a major squeeze on a market that's already in deficit. And the timing is critical. That pressure is going to be concentrated in the next 5 to 8 years, which makes the need for investment in new supply pretty darn urgent.
And this leaves us with one final, crucial question. We've mapped out the demand side of the equation. That first tank problem is coming into focus. The real uncertainty now is on the other side. Will the supply be ready in time?